Good afternoon, students. So we have come to the fourth unit. This is on Fourier transforms and Laplace transforms, and of course both are different, but both are related with input and outputs. In both the transformations, we have the solution of differential equation which relates input and outputs. We will discuss first Fourier transform and later Laplace transformation. Fourier transform means we have which transforms of the integral from one domain to another domain. I repeat, Fourier transform is a technique which having some integral transform from one domain to another domain. For example, when you take time domain, when you are going to transform from one time domain to frequency domain, we can change it, we can transform. Similarly, vice versa. From frequency domain to time domain, we can change it. Suppose when you are going to change, for example, when you take signal, your pulse is very large, for example, then the frequency will be very, very small. If pulse is very, very small, then the frequency, the pulse in time is very, very small, then frequency will be very, very large. If pulse in time is very, very small, the frequency will be very large. So this just vice versa. One quantity is reduced, the another quantity will increase. If another quantity is increased, the other quantity will reduce. This is exactly resembles with uncertainty principle, which we have learnt already. Uncertainty principle, and exactly Werner Heisenberg, he introduced uncertainty principle using this Fourier transform, this Fourier series. So Fourier series is a form, it's a wave form that will contain sine and cosine terms. I repeat, Fourier series that will contain sine and cosine term. So any waveform can be represented in terms of sine and cosine terms. Any waveform. So not only in mathematical physics or electronics or in physics it is used, it is also used in day-to-day life. For example, when we go and meet the doctor will check up our heartbeat, and this is like exactly time period, and he is able to hear the frequency. So for example, musician plays music in time, but we are able to hear in terms of frequency. So this is something like that. And we have some electrical circuits in electronics lab, and these input and output, they are related. So in all day-to-day life also it is used. This was introduced by Joseph Fourier in the year 18th century. Joseph Fourier from France, and his teachers were Laplace was his teacher. Lagrangian also was his teacher in France. So with this introduction, we will start Unit 4, and Unit 4 contains, these are the topics. So we are going to have some definition of Fourier transform and its inverse, transform of Gaussian function and Dirac delta function, Fourier transform of derivation, cosine and sine transforms, convolution theorem, one of the properties, and some applications. Applications goes with like this. We have flow of heat in an infinite and in semi-infinite medium, wave equation, vibration of an infinite string and of a semi-infinite string. Then the second division is Laplace transformation and its inverse transform derivation and integral, differentiation and integration of transform, Dirac delta function. So some applications of Laplace equation is nothing but on potential problem in a semi-infinite string. So these are the topics that we are going to cover in this unit. So as I said earlier, the Fourier transform was introduced by Joseph Fourier from France. So it's a mathematical transformation employed to transform signals between one domain to another domain. So mainly it is from time domain to frequency domain, or from frequency domain to time domain. Of course, we know that nu equals 1 by t. Correct? We know nu equals 1 by 2. Nu is the frequency. Time is the time. So nu equals 1 by t. T is the time. So it is a tool that breaks a waveform into many sine and cosine terms. Alternative representation characterized by sine and cosine terms. It shows that any waveform can be rewritten as the weighted sum of sinusoidal functions. So any waveform that we can write in terms of sine terms. See, for example, when you take this is a sinusoidal wave, this is another sinusoidal wave. You just combine these two, will get exactly square type. Okay, so introduced by Joseph Fourier, who showed that any periodic signal. So these are all periodic signals. Look at the waves; they are all periodic signals. See, period in time, period in frequency. So any periodic signal could be represented by a series of sinusoidal functions. So composition of first and two functions will give the bottom one. So this is what is given on the picture. As I said earlier, you have one signal. Okay, you have one signal, and corresponding Fourier transform is this one. This is your corresponding Fourier transform, and this signal, look at the time period, it enlarges. Here it is large, it is enlarged, it's large. What of the Fourier transform? It is narrow. So whenever it becomes larger, this will become narrow. Whenever it is narrow, this will become larger. So this is exactly vice versa, like uncertainty principle. So Fourier transform is a type of mathematical transform that relates input and outputs. The Fourier transform transforms a non-periodic function f of t in time domain into frequency domain. So there's a relation between your f of t and f of s, which we are going to see now. In its corresponding frequency domain, it's a tool to break a function into a sinusoidal forms characterized by sine and cosine terms. So if you have lengthier term, we can break into sine and cosine terms. What we call this is Fourier series. To understand the conduction of heat, so these are all applications: heat, wave propagation, digital signal processing, image processing, filtering. So everywhere it is used. So these are the areas the Fourier transform is used: signal analysis in electronics, sound filtering, partial differential equations. As I said earlier, the solution of differential equation which relates input and output is nothing but Fourier series or Fourier transform. Image processing, conduction of heat, and wave propagation. So there are mainly two formulae which are related in Fourier transform. One is, we are going to take the Fourier transform from one domain to another domain. We are going to use this formula. F of s equals 1 divided by 2 pi minus into plus infinity f of x e power ix dx. See, look over here, this is s, this is x. So s is in one domain, x is another domain. It can be either input and output. So this will be your input and this will be our output, which relates input and output. So this is what I said earlier, which relates input and output. Input is x, output is s, which relates input and output. So this is your Fourier transform. You have to learn by heart this formula. This is Fourier transform formula. Inverse Fourier transform is just do it on the other way around. Your f of x equals 1 divided by 2 pi f of s e power minus is x ds. Okay, don't forget these two formulae are very, very important, which involve in Fourier transformation. Okay, Fourier transform. And of course, we know that e to the power I theta, Euler's formula. We'll have to know all those things. So we'll have to use, we'll be using often this one. E power I theta equals cos theta plus sin theta. E power minus I theta equals cos theta minus sin theta. If we add these two, this will get cancelled. You will get 2 cos theta. Adding these two terms, you will get like this. Suppose if you subtract, this term will get cancelled. You will get, adding these two terms, you will get this. So often we'll be using this one. Okay, so you learn by heart. E power x is always related to sine and cosine. Okay, so now we'll try to solve some few problems. Sketch the following wave function in the time domain and calculate it by using Fourier transforms. So f of s is given as 3 in this interval and 0 otherwise. I repeat, f of s is given as 3 in this interval. So in this interval, answer is 3. Otherwise it is 0. It means in this interval, s lies between -2 and plus 2. S lies between minus 2 and plus 2. In this interval, your f of s. So this is your f of s. This is your s. So f of s equals 3. Otherwise it is 0 means you have 0 here, or this also you have 0. Is it okay? Now we are going to find out. We are going to find out f of x. We are going to find out the Fourier transform of this one. Is it okay? I repeat. See here, f of s is given. F of x is asked. That's all. F of s is given. Okay, f of s is 3 in this interval. This is 1, this is 2, this is 3. Okay, f of s is given as 3 in this interval. F of x is asked. Use this formula. We are going to use this formula. So you have f of x equals f of s e power minus isx ds. And what is f of s? It is 3. It is 3 e power minus isx ds. Okay, so you have now just integrate, that will give you e power isx divided by minus ix. Is it okay? We have integrated with respect to s, not x. This is s. Okay, so that will give you minus ix. Is it okay? So with the limits minus 2 to plus 2, you substitute for s or x. You substitute for yes, very good. You have to substitute 2 for s, not for x. Okay, because we have integrated with respect to s. So now just to substitute, that will give you 3 e power minus. So here before that I will change the limit. See here, e power minus ix divided by minus ix. Okay, now removing this minus sign, I will change the limit. I will change, see here, 2 minus 2. Here it is minus 2 to 2. I will change the limit. Now that will give me 3 divided by ix. You substitute the limit now. E power plus ix2 minus e power minus ix2. Is it okay? Now multiply, divide by 2. So this will become 6. Divide by 2i. I just take 2i in here. Already I know that 2i. See here, 2i. E power I theta minus e power minus I theta divided by 2i is nothing but your sin theta. So that's the reason that this can be written as 6 divided by x sin 2x. Is it okay? Sin 2x. See, we started with f of s. We ended with x. See, s and x. See here. We started with one variable. We ended with another variable. This can be input and this can be output. That's the relation between input and output, which is nothing but your Fourier transform. That's all. That's the idea. Every waveform that can be converted into sine form. Longer sine waveform can be divided into small parts of sine terms and cosine terms. So this is the idea behind Fourier series and Fourier transforms. Is it okay? Any doubt? Now we will go for some other problem. Find the Fourier transform of f of x equals 0 in this interval. X is less than a and 1, x lies between a and b. 0, x is greater than b. So this is the problem. Now just look at the limits. We are going to change into the same form. Easily we can understand this. See, as I said, x lies between a and b. X lies between a and b. So during this interval only answer is 1. If x is less than a, answer is 0. If x is greater than b, answer is 0. So either side answer is 0. During this interval alone answer is 1. Is it okay? So this is what is given. Now Fourier transform of f of s is given by this formula. We know already. Minus infinity to plus infinity we know already. So minus infinity to plus infinity. But there are 3 limits. Minus infinity to a to b, plus b to infinity. So we can make into 3 limits like this. The same formula, minus infinity to a to b, b to infinity. Is it okay? Now what's given here? In both sides the answer is 0. So both side answer is 0. So this will become 0. That one also will become 0. You have only the second term alone. So you have f of x e power isx dx. What is f of x in this interval? It is given as 1. It is given as 1. So you have f of x nothing but 1. So e power is x dx. Now after the integration you will get e power ix divided by is. Apply the limits. So apply the limits will give you 1 divided by 2 pi. So e power isb divided by is minus, you have to apply the lower limit. So e power isa divided by is. You pull is out, is common. So that is, so you will get as e power isb minus e power isa divided by is multiplied by 1 divided by root 2 pi. So this is the required Fourier transform of the function. Okay? Is it okay? F of x is given, f of s is c, f of s. This is input and this is output. That's all. That's a relation. This is nothing but Fourier transform. Now we'll go for some other problem. So f of x is given as x when mod x is less than a. So this is somewhat tricky. Okay, mod x is less than a and 0 mod x is greater than a. We are going to make this one in the interval form. See here, I repeat, you have mod x is less than a as it is given in the problem. Okay, mod x means x can be either positive or negative. So x is less than a or minus x is less than a, correct? Is it okay? Mod x means x and minus x. So you have plus x less than a or minus x less than a. Now I can bring this minus term to this side, changing the greater than sign. Okay, less than sign I have to go with the greater than sign. So I have brought this sign here and I can write this as x is greater than minus a. Is it okay, everyone? Now I can write this as same thing, minus a is less than x, correct? Now I am going to combine these two. So x is less than a, minus a is less than x. It means x lies between minus a and plus a. So mod x less than a means this interval. Any doubt? Very simple idea. Mod x is less than a means x lies between minus a and plus a. Now of course similarly x is greater than a. If x is greater than a, this can be minus x greater than a. You pull this minus sign to that side. So you will have x less than minus a. So x is greater than a, answer is 0. Similarly x is less than minus a also, answer is 0. Is it okay? X is less than minus a also, answer is 0. X is greater than a also, answer is 0. So on either side answer is 0. This is your 0, limit is 0. Whereas x lies between minus a and plus a, answer as x. Is it okay? So during this interval we have the x and these limits we have the value 0. Okay, any doubt? So we are going to change this limit into this limit. Easy to do the calculation. So we have changed the limits now. So x, when x lies between minus a and plus a, 0 otherwise. Now use as usual Fourier transform formula, which is nothing but your f of x equal to 1 divided by 2 pi minus and plus infinity f of x e power is x dx. See here, Fourier transform of f of x is nothing but f of s. This is capital F of s. This is small f of x. It means Fourier transform of f of x is nothing but capital F of s. The Fourier inverse transform of f of x is nothing but your f of x. Is it okay? It's on the other way around. Now, as usual, we have three intervals. One is x is less than minus a, another one is x is greater than a, then in between we have minus a and plus a. So as usual, if x is less than minus a, x is greater than a, these two terms, first term and last term will become 0. Okay? Answer is 0. And only second term alone exists. So we have 1 divided by 2 pi integral minus a to plus a f of x e power is x dx. Is it okay? Now we are going to integrate this. X e power is x dx divided by dv. We are going to integrate now. Okay. So now there are two methods we can integrate. Already we know that integration of u dv equals uv minus v du. This is famous one. correct, which we have already solved so many problems using this formula. Integration of u dv equals uv minus v du. But another one formula is there, Bernoulli's formula. Bernoulli's formula says integration of u dv equals uv minus the integration of u multiplied by differentiation of u multiplied by the integration of u. I repeat, integration of u dv equals uv minus differentiation of u multiplied by the integration of v. The series is going on because we are talking about only Fourier series. It will go on. So that's the reason that we are using only Bernoulli's formula instead of that ordinary one. It goes on until you get 0, until you cannot differentiate or integrate. Okay, so it doesn't matter, we will get to know. Now x e power is x dx, we are going to consider this as dv. This is your u, see u dv, this is your u, the whole thing as dv. So the whole thing as dv means you will get v as e power isx divided by is. dv is this one, whole thing. You are going to integrate on both sides. So that will give you v, the value for v. v is nothing but e power isx divided by is. So first we will just take Bernoulli's formula, 1 by root of 2 pi, your x is there, u is here, this is your v, e power isx divided by is, this is your v, minus, you will have to differentiate this. So that will give you 1. Integrate again, integrate, multiply. We are going to integrate, this will give you e power isx divided by, already one is is there. Again you will have to write one more is. Is it okay? Can you understand this? This is your v. We will have to integrate again. So e power isx divided by is is there. We are going to integrate. So that will give you e power isx divided by is. Okay. So you just apply the limits now. Minus a to plus a. Now we are going to substitute. So we will substitute first upper limit. So that will give you a e power isa divided by is. You substitute here. Before that, I into I squared minus 1. So this minus is there. So that will become plus. So plus. E power is, you substitute a here. E power isa divided by s into s squared. Minus with the lower limit. You have to apply the lower limit. So this will become, instead of a, you substitute minus a e power I minus isa divided by is, minus will become plus, you will have e power minus isa divided by, you have s squared, c s squared. Now you combine s terms, you combine s squared terms. Wherever you find s, you combine, wherever you find s squared, you combine. So this one and this one you can combine together, and this one and this one you can combine together, correct? So we will combine first this one and this one. So that will give me a e power isa minus plus. So this will become e power isa by s squared. Okay, this is okay. So one a is missing here. Okay, we will find out. So one a is missing here. Similarly, e power isa by s squared minus will give you e power minus isa by s squared. Here one a is missing here. Yes, a is missing here. Okay. Now, okay. So now we are going to combine these. We are going to combine these two. Now, is it okay? 1 minute. See, we have written like this. This one and this one. So no, it's correct only. This is correct. This is correct. So no problem. See, a e power isa by is is here. This time I have written here. Minus plus a e power isa by is, and this term I have written here. Now we are going to combine this term to this term and this term to this term. Okay. Now everything is correct. No problem. You are going to combine this one and this one. When you are going to combine this one, that will give you a divided by is and combined terms. E power isa plus e power minus isa. Then you are going to combine 1 by s square term, that will give you this. What is this one? This will be your 2 cos SA. What is this one? This will be your 2i sin SA. Can you remember these two formulae which I said earlier? Often we will be using this formula. So you will have 2 cos A. Here I can write this as multiply and divide by I. So that will give me 1i squared is there. So here in the numerator 1i will be there. So minus ai divided by s. And here I have written as it is. Now taking the LCM, we just take the LCM. So that will give you, here s will be there. So your s squared will be there. So I have written s squared here. I have written this term to this side and this term to this side. Taking common terms 2i out. I have taken 2i common out. 1. Second one is, I have written this term sin SA minus, I have multiply and divide by s. So that will give me minus as cos SA by s square. Is it okay? Now here this term can be simplified as multiply and divide by root 2. Root 2 by root 2. Root 2 and root 2 will give you 2. That 2 and this 2 will get cancelled. So we have root 2 divided by root pi. That can be written as root 2 divided by pi with I. This term as it is. So this is the answer. Any doubt? Anywhere? Any doubt? So now we'll go for the next